Hi everyone, welcome to another video, and in this video we're gonna discuss about binary tree. A binary tree is a tree structure where every node can have max 2 nodes, and we're gonna implement a binary tree using JavaScript. Let me explain how we're gonna implement this uh, on the whiteboard. So in a binary tree, let's imagine that we have a node with value 1, and when we insert a value, the first value will go to the left node, maybe 2. Then we're gonna insert value 3, and let's insert 4 and 5. Then we insert 4 and 5, it's gonna check again 2. It will insert 4 here, then it will insert 5 here, and then if we insert more, then it's gonna insert 6 here, and so on, right? And every node here can have maximum 2 nodes. The order of the nodes are not important here because we are not implementing a binary search tree and those kind of stuff. So the only rule we have to follow is that every node can have maximum 2 nodes, and we will be inserting the nodes from left to right, or a level order traversal. So when I say level, we're gonna insert it in level order, in the sense first we're gonna insert 1, then we're going to create 2 children. So the 2 children we're going to insert in a queue, for example left and right. We're going to insert that in the queue, left and right. Then we pop left, and we'll see if left is blank, then we insert in left. If right is, then if left is full and right is blank, then we're going to insert in right. And then again we're going to pop the right one, then we again see if left is blank or left is null, then we insert here in left. If left is there and right is null, then we're going to insert in right, and so on. And again we're going to input the values. While traversal, we're going to keep doing the same thing. So while inserting, once we insert, we're going to break the loop. But while traversing, we're going to do the same thing. We're going to put 1, then we process 1, then we put left and right to the queue, and we're going to process those, and so on. But while processing, either we can use a queue or a stack, because our goal is to touch all the nodes, not inserting in order or something, right? While processing, we can use a stack or queue, depends on whatever you feel good. Our goal is to just process every node. So let's implement this binary tree using JavaScript. So first I'm going to create a node. The node will have like a value and left and right. So constructor, I'm going to take a value, it is default value null, and this will have this dot val equals to val, and by default this dot left will become null, and this dot right equals to null. So this will give us the basic node. Then we're going to create our tree class. And in this tree class we're going to create our root. Constructor, then this dot root equals to, we're going to insert a val here. If val present, we're going to create a node, right? If val present, then we're going to create a new node with that value. If not, we're going to assign null to our root. Then we're going to create our insert method, right? It will take a value, and then it will traverse from left to right to see if left is not there, it's going to insert in the left. If right is not there, it's going to insert in the right, and it will do the things from left to right. So left node equals, let's create an array, this dot root, and then we're going to traverse it while nodes dot length, and current equals to nodes.shift. I'm using shift instead of pop because we will be implementing a queue. So we will be pushing from the right side and then popping the value from the left side. So basically we are using a queue. So then we have to check if current.left exists or not. If current.left not does not exist, then we're gonna create the value. Then we're gonna create the node to the left. Then cur.left equals to new node, and we're gonna give our value. Else, if cur dot right, then cur dot right equals to new node left. And because we are inserting, the time we insert a value, we don't have to proceed, we just have to break the loop. So we can return here. Also you can return here, but if not, we're gonna push our nodes, right? Else nodes dot we have to nodes dot push your cur dot left and cur dot right. Perfect. So this will take care of our inserting a value. Then we're going to create a traverse function so that we can traverse to every node, so that we can we can pass a callback and do our operations on a particular node. So yeah, we can create a trav function that will take a callback. Then we're gonna do the same thing. We're gonna take nodes equals to, when I create this dot put, and then while nodes dot length, let current equals to nodes dot, we can use shift or we can use pop, both here, because our goal is to touch all the nodes, not to insert from left to right. So let's use pop because pop is OF1 operation. So yeah, then we're gonna call our callback. If current exists, then we're gonna call our callback to cb dot call. Then we're gonna do this, and we're gonna pass our current node, and then we're gonna, if current exists, then we're gonna push our nodes, right? Nodes dot push, same thing, current left and right, current left, current dot right. So yep, this should do the trick. Okay, now let's see our test cases. So if you see, I have created a node with 1, then I inserted 2, 3, and 4, 5. So our tree will look like this. The node root node will be 1, then 2, 3 will be from left to right, and 4, 5 will be here. And yes, so when we try to evaluate the root.left value, it should be 2. Root.right value should be 3. And the same way, root.left, if you want to check, it should be 4. And then I am calling our traverse function and multiplying every node value with 100. So after multiplication, every value need to be uh, into 100. That is like 2 become 200, 3 will become 300, and I can check the same thing like root dot left dot value. Now it should be 200, and same the right one should be 300. Now let's run the test cases, and it passed. So that's all about binary tree. And yeah, thanks for watching.